Hello. It's been a while since I've done a lecture series, so I'm going to do a quick one right now. And I'm going to start calling them Tea with Katie. And the first one I'd like to give is on color. So it is midnight, so bear with me. Um, I want to talk a little bit about color and how our eyes work and how paint works and how computers work. Because I guess some people don't know this stuff, which is cool. Um, there's subtractive color and additive color. And we think about primary colors. We have primaries for both of these. So I'm going to talk about that. And this all sort of came out of a discussion which is how do we get yellow when we look at our computer screens? So our computer screens use LEDs, and those LEDs are red, green, and blue. So every pixel, if you zoom in, your computer screen has basically little lights. And so when you have each light is composed of a red, blue, and green component, and when those components are at full blast, when they're all at 100%, if you zoom out, that's how you get white light, those three colors combining. And if they're all at 0%, then that's black. And so the mixes of those wavelengths of those colors are how you get the rest of the spectrum from a computer. So if you've ever printed something and it didn't look the same colors as on your screen, that's partially why, because RGB and then CMYK, which is printer ink, so cyan, magenta, yellow, and black, K stands for black. Um, those don't always translate. And I'll talk a little bit about that too. There's certain things that you can only do in the physical world and certain things you can only do in a computer. So, um, much to discuss. But yes, so this is an awesome image from How Art Works, and that sort of demonstrates how you get yellow. But yes, so there's two kinds of light. There's subtractive and additive, and subtractive is like painting. So if you've ever painted before, you know if you mix red paint and green paint, which are opposites on the color wheel, you end up with brown or a black or a gray, something um, pretty desaturated, pretty dark. Uh, However, when you have a red flashlight or in a green flashlight, or if you have white flashlights with red cellophane and green cellophane, when you mix the two, you get yellow. And so these are different functions in the computer and Illustrator. So this is the multiply, and then this is the I believe, lighten. I just set this document up, yep, earlier. And so the interesting thing is if I'm smart enough, which we'll see if I am, we can add the blue and get um, RGB and CMYK. So there we go. So when you mix, if you think of these as paint, um, like if you mix all of these paint colors together, you'll get, teal if you mix green and blue, and you'll get something relatively purplish if you mix red and blue. Although that's an issue with paint, which I'll talk about in a bit. And then if you mix them all, you get close to black. And then if you think of these as flashlights, then when you mix the three like light bulb primaries, red, green, and blue, you get white light in the middle. But what's maybe more interesting and counterintuitive is this is actually how you get CMYK, which is interesting. So yellow comes from red and green being mixed. Magenta is when blue and red light are combined, and then you get cyan from green and blue. And that's maybe slightly intuitive if you think about paint. Like if you mixed a blue and a red, you would hope for something pinkish or purplish, and you can think of cyan as a mix of green and blue, but you'll see these colors are actually a little bit brighter. And maybe the best way to think about that is when you're combining light waves, the more light you have, the brighter it gets. And that's how you can get white light. That's, I guess, not exactly how it works, but that's mental shorthand for me to understand how you could go from mixing all these different colors to getting something that's just white. So that's interesting in my opinion. A couple other things that I was talking about with my mom this week. She asked me, why isn't brown in the rainbow? Which is an excellent question. And I said, well, it sort of is. And so this is orange. And if you desaturate orange, if you bring it all the way down to black, somewhere along here you'll get brown. So brown is just a darker form of orange. Um, this isn't exactly how this works, but you could think of someone who has orange or red hair. That's one of two kinds of melanin. There's a darker melanin that's brown and black, and then there's the lighter melanin, which is reddish. Um, but you can sort of imagine that that color spectrum exists in nature. It's one of the things that we see. That's obviously a little bit different than playing with saturation on a computer. Um, but this technically, brown is in the rainbow. If you had a really desaturated rainbow, um, brown would be there. Similar question two is what about pink? Pink is not in the rainbow. And the way we get pink, um, unless you're talking about pink, which is like truly like a very light red, which you could get. Um, so, for example, if you just choose red and you play around a little bit, um, a very light red will be kind of like a salmony pink. Um, so that's uh, not desaturation, but just getting lighter. This is, I guess, technically in the rainbow, but pink is actually a mixture of violet and red wavelengths. Purple, different shades of purple, similarly, are not technically in the rainbow, but they're mixtures of light. And there's all sorts of very interesting science and art about different combined wavelengths and how you can actually achieve what feel like or look like different colors to participants in experiments by mixing different wavelengths. I don't want to really say mixing wavelengths because that's not exactly what's happening. You don't mix light the way that you would mix paint, for example. But by combining different levels of, I guess, light exposure from different colored bulbs or whatnot. So it's all very interesting. One of the reasons this is such a fun thing to talk about is because light is and color are the intersection of the four different fields that I like to work in, which are neuroscience, philosophy, physics, and art. Uh, Color really is one of the only things that is sort of at that junction. And part of that is because color is something called qualia in philosophy, which means personal subjective experience that's influenced by the outside world, usually influenced by the outside world. So other ones are, pain, sensory experiences in general, in some ways emotions. And, the question, of course, is when I see red, is it the same as you seeing red? There's famous philosophical problems about this, like Mary in a black and white room, and you can read all about that yourself. But yeah, it's a purely physical experience in the outside world, but it's being perceived by a chemical and mental entity that is you and me. Um, so I think that's pretty interesting. And as an artist, obviously, color is extremely important. Um, and I'm very happy I'm not colorblind, but I also think colorblindness is such an interesting topic as well. And it affects, I think, one in every 12 men, which is pretty high incidence of something that's, such a different way to see the world. One of the other things I like to talk about is, um, I guess, so red-green color blindness is the result of cones being different in different people's eyes. So you have rods and cones. Cones are color perceiving light, or sorry, color light cells in your eyes. And rods are sort of black and white. So like how your sensitivity to light in general, white light. Um, so when the lights go off and you're in bed and it is dark and you see everything in shades of gray and black, um, that is your rods getting used to the environment. And obviously, this is all oversimplification. This is like a ton of neuroscience stuff. But it is absolutely fascinating. One of the other things I like to talk about is this thing, and I couldn't really figure out how to explain um, this issue I was having, but I like to think about, or like I was noticing that if I go over here and I have something that's purple and something that's yellow, and they're the same level of intensity or like the same level of saturation. Like let's say right in the middle here. So that's a yellow, and then this is like a middle purple. The yellow seems lighter, and like if you have crayons, for example, and you have a yellow crayon and a purple crayon, it always seemed to me that like purple could cover everything, but yellow couldn't cover everything if they were both equally transparent. And for a while, I couldn't articulate this because it seems insane to say yellow is a lighter color than purple because it isn't. Um, but I did some research a little while ago, and basically I discovered someone on the internet had written about this, which is that I think it part of it has to do with the sensitivity, like the way humans' eyes work, and we have sensitivity to different wavelengths, and we have three different cones in our eyes, and they're sensitive to different parts of light. And I guess it's sort of a feature of human eyes that we see something like yellow as brighter than purple, I guess. I'm probably explaining that poorly, and I would love to interview a scientist who can explain this better than I can. But this is an issue that I think about all the time. Um, Something else that's interesting, of course, you can talk about, you know, dogs don't see red, but most dog toys that get sold are red, or a lot of them are red, because the humans are the ones buying them. Um, and the mantis shrimp have like 16 cones. But do they see more colors, or does their brain process color in a different way? Do they see the same thing we do? So I think the shrimp colors was a question that U Chicago had as an interview or as a application question when I was applying to college. But yeah, all magical, wonderful, interesting things to think about. And this is what I do for fun. So thanks for listening. And sort of as always, I have these discussions to prompt more curiosity and not particularly to answer questions, but if people have questions, I'm happy to do little talks on them. So thanks for listening.